Hello, everyone, and welcome to The Cut. The Cut is the CERATIZIT YouTube show and series where we dive into topics from the CERATIZIT group from all around the globe. Today, our episode will be focusing on ToolScope, our digital process monitoring solution from CERATIZIT. I'm joined today by my colleagues, Martin Berndt, the product manager for digital solutions from CERATIZIT, as well as my colleague Eike Ohmstede, who is the head of digital solutions by CERATIZIT. And today we're going to be talking about ToolScope, a very exciting topic and digital machining solution that is coming from CERATIZIT. And we're going to take a little bit of a deep dive and talk about ToolScope. So Eike, what is ToolScope and what does process monitoring mean really for machining?
Yeah, well, so as you said before, the ToolScope is part of the digital solutions of the CERATIZIT group. And the ToolScope himself is more or less a small high-performance industrial PC, which is installed directly into the machine control of the cabinet. And on this industrial PC is running our firmware, so the ToolScope firmware. And we have a direct communication with the machine control. So this could be, for example, the Profibus or the Profinet connection, but also so for the Industrial 4.0, it's very important to have a different connection to the machine control. And there we have also the possibility for the OPC UA or also the UMATI connection to the machine control. So in any case, the ToolScope monitor the process. In standard, it's the load of the spindle. And if the process deviation is too high from the learned process, the ToolScope will stop directly the machine and avoid, in this case, further damages to the spindle, to the machine himself, but also for the workpiece and the tool.
So it's a very smart solution, obviously. I mean, the ToolScope learns the typical parameters at which your machine is running, and based on deviations from those learned, data and information, it can make adjustments on the fly. I mean, that sounds really interesting. Martin, what does this mean, though, for machining in general?
Yeah, maybe we are doing here a short example. If you're thinking about a forged component, we have here the challenge that we have fluctuating stock offsets. So we have that's an insignificant influence to the milling process. So we have here different workpiece qualities of the pre-machining that influence our process. So this causes a high safety offsets. That means that the tool is a little or not that even engaged. So we have here, in this case, fluctuating loads, and that have a big negative effect on the lifetime of the tool and on the process. And we are wasting here lots of potential of the tools. So that means also we need high quality control and measurements to ensure that our process is correct. So the solution here is that we have an active interaction into the process to react live into the process forces. So, and ToolScope solves this problem with the functions of the process monitoring, or for example, also the adaptive feed control to deal with these problems in the manufacturing.
Cool. That sounds very, very interesting. I mean, who are the typical kind of target groups? What are the type of processes and machines that ToolScope is really well suited for?
Yeah, we can think here on a medium and large series. We are talking here about, if you take a number, about 1,000 identical parts per year on one machine. But we are not only speaking about identical parts, but also identical processes. So the machine types we support, we have here, for example, Grope, SV, Hermle, Chiron, Stamer, Heller, and Schuster. And if we are going with Grope, DMG, or Chiron, we are the original equipment supplier. So that means that the customer can choose ToolScope when buying a machine at the machine tool builder. So sometimes if we are making, we have some problems, or say so, that we have some issues with the warranty, but that's not so. With these just mentioned machine types, we have no problem with the warranty, and also with the PLC project. The PLC project, we need this project to connect the ToolScope to the machine and to the control. So also at these mentioned machine types, you have no problem with the PLC project. The project is normally at the customer maintenance. We support the controls of Siemens, Farnung, and Heidenhain. And as a general rule, we can say that the tools not be smaller than 3 millimeters in diameter. But however, this depends, of course, on the size of the spindle, the material, and of the tool. So we can also say smaller tools diameters do also work. And last but not least, the customers with start difficulties in their manufacturing process are, of course, also optimal customers for us.
Cool, very interesting. I mean, so we're truly optimizing a machine and improving a machine. Also, like you mentioned, very important, it's not a machine hack where we're obviously voiding the warranties of the machine by adding this additional component. We're just making the machine smarter and more intelligent. And I guess that's kind of the point when we're talking about, digital 4.0 solutions and these type of keywords that you currently hear a lot in the market, but very, very interesting. How about like a really practical application example? Do we have some good examples of some use cases that we've dived into? Maybe Eike, you can explain a little more.
Yes, of course. So maybe we can go into an example of the automotive sector. So for example, the production of a common rail. So as you know, there is a strong competition in the automotive industry, and it's a mass series production, and the target there is always increase the productivity. And there we had a look to different machines where this rail is produced. And with our adaptive feed control, for example, we reduced the cycle time more or less to 15%. And this was a big benefit for the customer because they can produce more and more parts during the shift. Another point is here, for example, the wear optimization of the tool. So during the course of the knowledge of our application engineers, which we are upskilling to a digital application engineer. So that means we combine the knowledge of the classic tooling application engineer with the digital processes of the ToolScope. And this unique knowledge we can use for the tool life optimization for the customer. And so we save for the customer the tooling costs more or less for 30%. And another point was there to go into the process safety, and this goes up to 25%. And this was a big benefit for the customer.
Cool. Yeah, that's great. I mean, it's always nice to hear real use case examples to kind of reinforce all the stuff that we talk about, in particular, the advantages of ToolScope in general. Marty, I mean, what really are the advantages to utilizing a process monitoring system like ToolScope?
With the ToolScope system, we are able to select the correct settings for any process for any customer. So our system is able to monitor a wide range of processes, also because of the wide range of the settings we have. But if we are talking about process monitoring, we can do more because we're also talking here about the evaluation and the visualization of the data. So we can save the information in the classical way via, for example, Excel capable documents, and save these documents local or also in the cloud. But we can also display the specific information via our new tool, the Visual Shop Floor for ToolScope. So here, the information such as an OEE, so OEE means the overall equipment effectiveness, we are able to display histories and runtime analytics, and this can be all displayed via a web interface. So that's a very cool and new feature. And the big thing about the ToolScope and CERATIZIT is that we have the perfect combination from the knowledge from the cutting edge, from the whole CERATIZIT group, and we have the digital process monitoring. And this because of our 4 major brands that you all know. That's CERATIZIT group, that's the Comet, that's the WNT, and also Clank for aerospace.
Yeah, I mean, that's great. Obviously, data is all well and good, but if you don't learn from the data and you can't visualize and take good insights away from the data, then it doesn't really do you any good. So I guess our system is really well set up to not only record the data, but also display it in a way where you can actually learn and optimize your own processes. That's a very great point to talk about. All right, well, let's we know why it's advantageous to utilize a process monitoring system. Let's talk a little bit about how ToolScope actually achieves this. How does ToolScope work?
Yeah, we have here 4 big functions. These are the process monitoring, that's wear monitoring, the adaptive feed control, and the collision control. So, and I think we can dive here into these 4 functions a little bit. The process monitoring is the classical function. So maybe look here at the example of the machining wheel hub. So we see on the axles the utilization of the spindle motor and the time in seconds. And the red signal shows the process force of the spindle motor. And the green lines right here are the tolerance bands. And these tolerance bands have already been thought. So this process is known to the ToolScope. If the process is unknown to the ToolScope, we need up to 3 to 5 repetitions so to teach in the process. Later, it's also possible to make some fine adjustments by the machine operator. It's just a few clicks and the tolerance bands are set up perfectly for the process. As long as the signal is between the tolerance bands, we are dealing with a very good process. And if a limit is violated, in case of a tool breakage or something like this, ToolScope reacts in real time with a direct machine response. So in the drilling process, that would be a direct stop in the feed and the spindle stop delay a few seconds to allow the cut, to allow the tool to cut free. And afterwards, the spindle stops and the process is safe. If we talk about the next function, the wear monitoring, here we see, like in the process monitoring, the advantage to the advantage torque. It's plotted here, but per process. And on the other side, we see the number of holes. To set up the wear monitoring, we need also a yellow line, and it's yellow line. It's called the wear limit. The wear limit. A few words about the wear limit. This is automatically determined by the system, but it's an empirical value. So we have to check out this value to make it perfectly for this process. The red dots right here are the advantage torque. So in if we are machining this process right here, the wear is going to be so with increasing wear, the forces are also going up. So and sometimes we're going to touch with the red line, the yellow line, and if this is happening, ToolScope send also an alarm to the machine and makes an direct machine stop. So here we are able to monitor the wear of the tool.
I mean, that's incredible, the ability to, the potential savings are enormous. I mean, before you destroy your machine or destroy your tool, the ability to have the machine stop and take a look and analyze what's going on and what's occurring. I guess those tolerances, once they're dialed in, can make a series production, it gives it the potential to be, almost fully automated. And that's a huge advantage to production lines. What are some of the other features or the functions that we wanted to discuss?
Yeah, so example, the adaptive heat control. So as I said before, with the rail, for example. So here in this example, we see on the left side the time force diagram, and in the center, the tachometer is showing the feed rate between 80 and 120%. So the teaching of the control variable is, for example, the optimal load of the tool. And this takes place under more or less 100% of the feed rate. So shown here as an example during the machining of a full groove. Afterwards, we see the same machining again, but it's activated the adaptive feed control because it's obvious that the green control variable has been set. So this is our limit. So this means as long as the time limit is not reached, the ToolScope will control up to 100% in the material, which fluctuates between 100 and 105%. When we are leaving the material again, so it goes up to again to 120%, and in order to save further cycle time. So if we are not in the material, we can drive faster. The result would be a more or less moderate cycle time around 5 to 10%. It becomes more interesting when there are fluctuating machining parameters. So here it's a demonstration by machining a ramp from 0xD to 2xD. At the entry, control is already slightly below more or less 120%. As the cutting deep increase, the control variable is soon reached. To avoid overload, the ToolScope starts to control below 100% to protect the tool and also the machine. So in summary, we achieve an optimal balance to the tool protection and the cycle time reduction. And this is more or less about 5%, for example. The cycle time reduction is depending on the machine, on the process as well. And in standard, we say it's between more or less 5 to 15%.
I mean, those numbers are great. I mean, when you're talking about a big, large series production, increasing tool life and reducing cycle times leads to enormous potential time, cost savings, and just better optimized processes. So yeah, that's really, really great. How about, let's talk a little bit more about, protecting the machine itself. I know one of the functions is collision control.
Yeah, so the collision detection, for example, is normally used, for example, at a customer who has only a small lot of series, or the single lot production, for example. So if they use, for example, different programs, different pallets, different workpiece, and maybe the operator choose not the correct pallet, so the machine, there could be a collision and the machine has a further damage. So another option could be, for example, the tool length compensation. And this is maybe not transmitted correctly to the control. So here we have an example. The measuring is 75 millimeter for the tool length, for example, but the operator just enters 7.5 millimeter. So that means the tool is practically 67.5 millimeter too long. And we will first demonstrate the effects of this collision detection or collision with a standard machine overload detection. So that means it takes a few hundred milliseconds if the machine detects this overload and stop the axis. So normally the feed axis try to push the axis to the target position. And this means normally the spindle is damaged, the axis is damaged, or some other topics of the machine.
The tool, so the component as well,
detection,
right? Yeah.
Of course.
Yeah.
And our collision detection is working in this way, that we install an acceleration sensor close to the fixed bearing of the machine control or of the spindle, so that we are more or less close to the tool and see the vibration directly on the tool. So that means if we see such a collision, we react more or less under 1 millisecond. So this is the big benefit, that there is a really fast reaction, and we choose directly emergency stop for the machine, and this machine stops, and it's more or less like an airbag of the machine control.
Yeah, excellent. I mean, wow, you know, the combination of all of these types of functions from the ToolScope system allows for an incredibly flexible and agile system. I mean, it can really be custom adapted to support, you know, a number of different types of processes. That's really a great advantage to the system, I think. So, you know, with you know, different functionalities, you're able to pick and choose what best suits your own particular production or manufacturing processes needs are. How about like documentation? How is the data collected, and what are some of the documentation and digitalization kind of tools utilized to represent this data that's being collected?
So in addition, when we talk about documentation, so the digitalization is also an important part. And especially because of the current pandemic situation, the remote support becomes more and more important. So because of travel regulations and so on, it's not easy to enter the customer plans. And so if the customer have a problem with the ToolScope or with the process himself, so we have now the possibility to log into the ToolScope from all over the world, out of the office, and to give our customers the support which he needs. So in the best way, for example, and it's also possible if we have some problems with tooling and so on, so we can use the experts for the tooling or the digital application engineer, which I've talked before. So it's really important and a big benefit for our customers and also for us to give them the service they need for the moment, so that their production runs in the best way.
Yeah, I mean, that's definitely a major advantage of ToolScope being a digital service as part of CERATIZIT and CERATIZIT Cutting Tools division. We not only providing the digital solution, but we provide the tools as well. So we have a number of different experts within the group. Also, as you mentioned, the remote support, but the support in general is very important. We don't just provide a customer with a piece of hardware and say good luck. Obviously, it's a very complex integrated system, and the support is critical from CERATIZIT in order to implement it in a successful way to truly optimize production. Yes, that's definitely, I think, one of the key points about ToolScope is that it's not just a piece of hardware, but also a process optimization in which we fully support the customer along the journey. Let's talk a little bit about, you know, why choose ToolScope? Obviously, there are some other competitors that offer similar systems out on the market. Why would a customer choose ToolScope over some of those alternatives that are available?
Yeah, Brian, you just mentioned it to the point. Because of the CERATIZIT Cutting solution, we combine these four major brands with CERATIZIT from the insert tools and turning and milling, with Comet with the insert drills and reamers, with W&T with HSS and VHM drills and mills, and also the systems for tool and workpiece clamping, and also Clank for the aerospace industry. With all these competence, we are the optimal cutting expert, as you just mentioned. And then there's coming our digital application engineer, or DAE, and our digital sales engineer, the DSE. So these persons are the perfect people for the job. They know everything from the cutting edge, and they know perfectly the ToolScope system and can adjust it right to the customer. So that's our key point where we are much better than our competitors because of this service we can offer to the customer.
Awesome. Yeah. So that's definitely a great point. CERATIZIT is the cutting tool solution, and that's what we like to talk about when we talk about cutting tools. Not just here are the tools, you can get them quick, good luck. We provide a completely full service, full range portfolio access to our experts in all of those particular competencies that you mentioned before. And that's what the cutting tool solution from CERATIZIT is all about. Maybe, Martin, you can fill in our viewers about where they can find some additional information. If you're interested in ToolScope, what are the first or the next steps to getting some more information?
Yeah, sure. If you already have to get contact to CERATIZIT, just ask your employer, your CERATIZIT employee. So he will get you also the information about ToolScope and process monitoring. If you are not in touch with CERATIZIT until now, you can join our website and see there the information also about ToolScope. Or if you have a direct question, you can just write an email to toolscope@ceratizit.com, and we will take care of your request and will answer as soon as possible.
Excellent. Yeah. So thank you, everyone. Thank you, Martin. Thank you, Eike, for taking the time to join us here on The Cut. You can check us out at cuttingtools.ceratizit.com. Type in ToolScope in the search bar and you'll immediately find access to our landing page, which contains lots of different videos and information where you can take a deeper dive on the topic of ToolScope and process monitoring. If you're interested in ToolScope directly, you can also send an email to toolscope@ceratizit.com. There, your question can be directly addressed and answered by our experts. And yeah, thank you everyone for taking the time to join us and view this episode of The Cut from CERATIZIT. Take care, guys.
Thank you very much.
Thank you. See you next time.
Bye.